Okay, so today we're going to review this reaction rate lab from reaction 7. Let's go ahead and look. Title, the pre-lab questions. You are supposed to answer these pre-lab questions before you go through the lab. So summarize the collision theory and how surface area applies to reaction rates. That was from the video embedded in the lesson. So collision theory, if you think about it, collision means to collide with something, to crash into something. Atoms have to collide, they have to crash into one another in order to actually have a reaction. And then surface area, if I have a greater surface area, are there greater chances that reactions could happen? What did the video say? What do you think? Well, we're going to find out in this lab as well. So pause the video, right in this box, type your answer, and then go on. Write a hypothesis for how surface area can affect reaction rate. So in this box, you're going to say, what do you think? If we have greater surface area, is the rate going to be faster or slower? Pause the video, go ahead and type in your response. Write a hypothesis for how temperature can affect reaction rate. So instead of surface area, this time you're thinking about temperature. If I have a really high temperature, if I have a hot temperature, is the reaction going to go faster or slower? Pause the video and type an answer in that box. Okay, so here's the procedure that we're going to go through. Okay, these effervescent and acid tablets, they're kind of like an Alka-Seltzer or something you might take for a stomach ache. You put it in water and dissolve it, so you can find these over the counter, but we're going to break them into 4 equal parts. One of the pieces will be used for each trial. We're going to measure about 15 milliliters of room temperature water, pour the water into a test tube, drop a piece of antacid into the water, and then immediately start the timer. Right, we're going to do that again, and then we're going to do the same thing again for cold water and for warm water. We are going to break apart one of the pieces, and we're going to crush one of the pieces for the cold water, the warm water, and the room temperature water. So let's go ahead through the lab itself. We're going to be recording our data here in the data table 1. You might notice here this error. It's because there's no information in there yet. When you type in information, you're going to get the formula will create your average for you. So that's done for you already. And then you're going to have post-lab questions to answer. So let's fill in the data table. We're going to go to the camera, and we're going to go through the lab data. Okay, so I have my antacids right here. Okay, I have hot water. I have hot water from my tea kettle. I have cold water. It was ice a little bit ago. I have room temperature water that's just been sitting out. We are not going to use a test tube like it said in the instructions, but we are going to use a beaker. I used a green piece of paper today instead of white because my tablets are white, so you'll be able to see them better in the video. So we're going to go to our graduated cylinder. We're going to get about 15 milliliters of water. So okay, we've got about 15 milliliters of water. You should always, when you are measuring with a graduated cylinder, get to eye level and make sure that you have, let's see, that's not very clear. Here's the 10 and here's the 15. So I won't show you that every time, but I will. I'm trying to make sure we are doing proper lab procedures in this demonstration version. So it said pour the water in there. Okay. Then it said we need to have a timer ready because as soon as we put our effervescent tablet in there, we are going to want to have our time. We're going to want to hit start on our timer. So we'll put our timer right here. We needed to break these in half. Hopefully, that was a pretty clean break. And then it said to break it into another half. So break it into quarters. I'll go ahead and break this one. All right. So I'm going to drop this into this water and hit start at the same time. And it did say in the instructions to stir it, so we're going to swirl stir. And that bubbles, that gas formation, shows us that there is a chemical reaction happening. We still have some, so we're getting there. Definitely getting there. We want it to be all the way dissolved. If there's just bubbles, we're going to stop. And that is our time, 1 minute and 38 seconds. So we're going to pull our camera away and add that. 1 minute, 38 seconds. Now hold on, our time says in seconds. So we need to have, we're going to say equals, 1 minute is 60 seconds. So we're going to say 60 plus our time said 38 seconds. And actually, if we went back to our camera, it says 1 minute 38.85. So we'll say 1 minute and 39 seconds. And so 99 seconds for that. Well, let's go back to our camera. We're supposed to do another trial at room temperature. So we'll clear out this water. Okay, we'll get another 15 milliliters of water. Pour the water in. Get our stopwatch prepared again. I'm going to reset that. All right, ready, set. Let's see if it's about the same time or not. I want to shake it too much because we didn't shake the other one too much. We want to make sure we're being consistent. We're close. Nope, I think we're good. So 1 minute, 24.7. So 1 minute, 25 seconds. So let's go back to our data table. Now, remember we had 1 minute is 60 seconds. So we got to go 60 plus 25 seconds, 85. So our average is 92 seconds for the room temperature water for just the piece of it. All right. So let's go ahead and get rid of that. And the next instruction tells us that we are supposed to get the 15 milliliters of water. All right. And then we're supposed to break this into several to get our 15 milliliters of water. And then we're supposed to break this piece into several other pieces. So let's go ahead and we'll use the package to break it up into several pieces. Okay, that looks like pretty good broke up into pieces. We'll get our stopwatch started. Okay, and let's see. Let's say ready, set, go. So yeah, it seems like there's a lot more bubbles in there to me. had a lot more surface area because we broke that apart. So in between the pieces, we had even surface area where reaction is taking place. So yeah, it's a lot faster. Almost. A couple little pieces there. And I think here. Good. Okay, so we stopped at 59.32. So just 59, then around off to 59 seconds. All right, so that was room temperature, and that was several pieces, and that was 59 seconds. Okay, so we got to do that one again. We're going to break it into little pieces. Okay, we're going to get our water. Keep forgetting to put the camera back on for you. Okay, so we are going to get our 15 milliliters of water. Okay, go ahead and pour that into the beaker. Then we are supposed to break this up into little pieces. I'll try to use the same size pieces just for consistency, but kind of hard because it's an Alka-Seltzer tab. It's going to break a little differently every time. All right, so let's get our stopwatch started. I guess it wants to go that way right now. Ready, set, go. Not close. Very close. I got a couple of little pieces. And we're good. Okay. So that dissolved at 50.4. So that's going to round off to just 50 seconds. Over here, and we'll put that in. Okay, so what's your prediction? If we crush a part of an Alka-Seltzer tab, which is the next instruction, is it going to be less than 54 seconds or more than 54 seconds? What do you think? Well, let's find out. All right. So we're going to get our mortar and pestle. We're going to have our little piece. Okay, we're going to crush it. Oh, that was an interesting sound. I try to make sure to have the same amount of Alka-Seltzer in there every time. All right, so now we have the crushed Alka-Seltzer antacid tablet. Okay, we're going to get our timer, and we're going to make sure that we are reset. So ready, set, go. You didn't even have to really swirl that one. And I think we're good. So 12.4, that's going to round off just to 12 seconds. We put in our data. Wow, 12 seconds is a lot less than the several pieces. So when we increase that surface area, it looks like the time's going down. Let's try it again just for clarity. Okay. And we've got our 15 milliliters of water. We're going to crush our quarter piece of Alka-Seltzer. Okay. And make sure it's not pressed too hard into our little bowl. And that back. Reset our stopwatch. And ready, set, go. think that was a little overdone, but 19 seconds. So into our data table. And that one might be a little bit of an error value because we sort of let it go a little bit. But that's still way less. All right, let's try the cold water. Okay. So we're going to come back to our camera. This part. And empty what we just did. Now we're going to use this cold water that is really just melted ice. And we have 15 milliliters of that. A little too much. Okay. We want to still use the same amount of Alka-Seltzer so that we have a good consistent timing. Okay. And get our timer ready. And let's see what happens. Hold on. So this is the cold water. Still going there. Well, we still have a piece there. Let's see. All right, that's good. So our time is 1 minute 48.19. So 1 minute 48 seconds. Let's go ahead and record that data. So that would be equals 60 plus 48. That's 108 seconds. So let's try it again. That data might be a little bit skewed because a little snafu with not pouring in the water at the right time. Okay, so we've got our empty beaker. We've got our ice water. Try to get the right amount of water there. Okay, we're going to actually pour in the water first this time. Okay, and then we have our piece of antacid tablet. Ready, set, go. This should be some good data. If you could see it, it would be good data. And you can see there's lots of bubbles there. Still got a piece. Just breaking up. think there's still a couple of little pieces down in there. I think we're good. All right, so 1 minute 51 seconds. So let's record our data. So that would be equals 60 plus 51. That's 111 seconds. So we weren't too far off with our little snafu on the first set of data. All right, looking at this, 100, we have cold water seems to take longer to cause with the chemical reaction. All right, so we're going to do the same thing again. Pull back over. This time we're going to have several pieces. So here is one of the quarters. We're going to get rid of what we had there. We have cold water. We need 15 milliliters of cold water. I'm going to pour that in. Then we have our Alka-Seltzer. We're going to put it back in the break it into little pieces. Ready. Okay. Ready, set, go. Bubbles on this one are making it a little hard to see. Must have a couple pieces there. Yeah. So we got more bubbles in that one. Turn it upside down. I can't turn it upside down because they're opened up, but you can see there's still some pieces in there. So, and I think that's enough. All right. So 1 minute and 12 seconds. So for that one, we're going to do equals 60 plus 12, 22. So that was faster by quite a bit. But still, it took longer than the several pieces at room temperature. So let's see. We need cold water, several pieces. So let's get some more of that ice water. And we'll try again. This time I'm going to remember to put the camera over for you. Okay. So we have our ice water. A little too much. Okay. Ice water. We have our packet for our antacid. I'm going to break it into several pieces. Okay. And then, let's see, water in the beak. Stopwatch. I'm going to reset that. Ready, set, go. All right. Seems like the several pieces does make a lot more bubbles, but maybe that's just more reaction happening on the surface. Okay, we're good. All right, so that one was 51. That was a lot faster. Maybe we had smaller pieces. It's kind of hard to judge. So let's go ahead and type in 51 seconds. All right, we're still averaging more time with the cold water than with the room temperature. All right, let's go with crushed on cold water. So we've got our empty beaker. We got our reset stopwatch. We have our cold water. All right, and we need to crush one of these pieces. So it looks pretty crushed. So we can make sure it's not all stuck to the bottom. All right, let's get our stopwatch back. Water in the beaker. And antacid in the water. Ready, set, go. No more solid material. Okay, 16.7, so that's basically 17 seconds. Go back and write down our data. All right, let's do it one more time. All right, so we're gonna reset our stopwatch. We're gonna dump out what we just did. We need a little bit more cold water. Okay, we need another piece of antacid. We are going to crush it. This is called a mortar and pestle, so you know. Make sure it's not stuck to the sides. Okay. Now. All right. So, water in the beaker. Timer ready to go. And ready, set, go. I think we're good. Okay, 26 seconds that time. So, look over here. We're going to put 26. Enter, and we got our average there. So, cold water is trailing as taking a lot longer as we go through. All right, let's try warm water from the tea kettle and do the same kind of things, same kind of activities with the water from the tea kettle. All right. All right, so let's go ahead with what we were doing here. We're going to start with the hot water from the tea kettle. All right, so I'm going to get 15 milliliters of the warm water, the hot water. Then we need to have our timer. I'm going to reset our timer. We have 1/4 piece, and we're going to say ready, set, go. 1 minute and 3 seconds. Let's go back and put our data in. And that is, so it would be equals 60 plus 3. How did that 63? But it's good for consistency, being able to remember how to do the formulas in Excel. All right, so we have another trial of the quarter piece. And we're going to reset our timer. Go full screen. Let's get our hot water. Okay, we got hot water. A quarter piece of the antacid tablet. Ready, set, go. Almost. I think that's it. Okay, so 57 seconds. We can just 7. Here's just our average of 60 seconds. Well, that is the fastest one so far. Fastest average. So it seems like warm water is going to go faster. Let's try the several pieces. And so we'll bring camera back. Okay, we need to dump out our waste there. We need our hot water. So we got hot water. We have our package so that we can break up the quarter piece into several pieces. Try to have the same size pieces as we did before. All right, so ready, set, go. I don't know. What do you think? A little bit more stuff in there. And good. 35 seconds. So. All right, one more time with the several pieces. Let's go back to our camera. Reset. Go. We need our package so that we can break up the quarter piece. All right. We need our hot water. All right. Hot water. Several pieces. Ready, set, go. So we are so close. Good. All right, so we look and we see it says 27 seconds. So we go back to our data. And that time was a little faster. Maybe we had a little less in our breaking. 27 seconds. Warm water is looks like the fastest one so far. So let's try crushed. Okay, we'll go back to our camera. And we got a reset camera. We're going to dump out the waste from the last time. So we have fresh, clean water. 15 milliliters of hot water. Have our crushed antacid. Make sure it's not all stuck to the edge. Ready, set, go. Well, I don't see any more solid pieces. So we'll go with 12.8, which would be 13 seconds. All right. Fastest so far. All right, let's go with one more just to get a good average so we have some good data. We will go back to our camera so you can see that. All right, so we need another crushed piece. We're gonna give it a good crush. Okay. Get our hot water out. All right, there's 15 milliliters. All right, so 15 milliliters hot water, crushed antacid tablet, and then ready, set, go. Oh goodness, that was pretty fast. Don't see anything. All right. All right, so 9.3 seconds. That was pretty fast. All right, so we can see our data table, and now it's time for you to analyze the data. We are going to use all of these numbers, and you can start answering these questions. What relationship exists between reaction time and reaction rate? So we look at the time. How did the time change as you saw those reactions happen? What statements that summarize the results of the lab activity? So write statements that summarize the results of the lab activity. What did we do? What did we find out? What did we see? Type that in this box. How does collision theory explain the reaction times? So what you're really looking at, if collision theory is atoms move around and they have to run into each other to make a reaction, are atoms moving around faster in cold water or warm water? Think about that. What has more energy, cold water or warm water? Okay, all right, so answer these questions. And that's this one. How does collision theory explain reaction times? All right.